Welcome to a tutorial on how to use JalTantra. JalTantra is a system used to optimize pipe water networks. Given the relevant information about a network, it will provide the user with the optimal pipe diameters so that the capital cost is minimized. Some of the assumptions we make regarding the network to be solved are: it has a single source which provides a steady head no matter what the demand. It is a branch network, that is, there are no loops in the network. And finally, network is gravity fed, that is, there is no pumping from the main source. Let us look at a sample, very simple network. Here we have node 1, which is the source. It is providing water to two nodes, node 3 and node 5. Node 2 is an intermediate node without any demand. We will try to find the best pipe diameters for such a simple network using JalTantra. JalTantra system is free to use and publicly available at www.cac.itb.acn/JalTantra. Here on the left side, we have a sidebar which displays all the panels of the system. Here we can see the four main options of the system. Network description, which contains the input forms to provide information about the network. Optimize network, from where you can tell the system to optimize the network and where the results are displayed. Load save files, from where you can load input files or save input/output files. And finally, the help section, from where you can get additional information about how the system works. We will now go over each option and look at their panels in detail. Let's first look at the network description panel. The first panel is the general panel, which contains input fields for the general information of a network. Let's go through the fields one by one. First, we have the name of the project. Let's just type sample for our test project. Next, we have the minimum node pressure. This is the minimum pressure in meters that must be maintained at all nodes by default. We can override this and give different values for different nodes, but this is the default value. Let's use a value of 5 meters for our sample project. Next, we have the default pipe roughness. For measuring head loss in pipes, we use the Hazen-Williams head loss equation. This is the roughness coefficient used in the formula. This is the default value used for all pipes, but can be overridden with different values for specific pipes. Let's use a typical value of 140. Next, we have the minimum head loss per kilometer. This is the minimum head loss in meters that is allowed per kilometer for each pipe in the network. Let's use a value of 0.01. Similarly, we have the maximum head loss per kilometer. Let's here put a value of 5 meters. Next, we come to the number of supply hours. This is the number of hours in a day for which the source provides water. This effectively determines the peak factor for the flow in the network. For example, if the number of supply hours is 12, then water demand for the entire day must be satisfied in 12 hours. This is equivalent to having a peak factor of 2. That is, node have an effective demand that is double their stated demand. For our sample project, let's keep things simple and use value of 24 hours. Finally, we come to some information regarding our source. Firstly, we give the node ID of the source. Node ID is a unique integer identifier that is given to each node in the network. Note that the node ID must be greater than or equal to 1. Let's give our source the node ID of 1. Next, we have the name of our source. Here, let us just enter source. Then we give the source head. This is the constant head in meters that the source provides no matter what the demand of the network. Let's enter 100 meters for our source head. Finally, we come to the source elevation. This is the elevation of our source node in meters. Let's enter 90 meters. Now we are finally done with the general information. Next, we move on to the nodes panel to enter all the information regarding the nodes of our network. The nodes information is displayed on a table with the following columns. Node ID, this is the unique integer identifier for each node. Node name, the name of a node. Note that this field is optional. elevation of the node in meters, the water demand of the node in liters per second. This field is also optional. If left empty, a zero demand node is assumed. And finally, minimum pressure. This is the minimum pressure in meters that must be maintained at that node. If left empty, it uses the default minimum node pressure value from the general information panel. To add a node, we simply click on the Add New button at the top. As you can see, it has already given a node ID number of 2, since we have already used 1 for our source. If needed, we can override this as use any integer value greater than or equal to 1. To edit, double click on the cell. Let's use 5 for our ID. To edit the rest of our columns, we can double click each of them one by one, or we can simply use tab and shift tab to cycle through the cells. Let's enter the details for our first node. For node name, let's enter node 5. Next, for elevation, let us put 70 meters, and for demand, put 2 liters per second. Let's leave minimum pressure empty, since we want to use the default minimum pressure value of 5 meters that we have already provided in the general information screen. Let us add 2 more nodes to our example network and quickly fill in their details as well. As you can see, the 2 nodes were given node IDs of 2 and 3, since for the first node we used 5 and 1 was already used by the source node. We will now fill some details for the 2 nodes. For the second node, we gave it a name of 0 node, since we don't have any demand. That is why we leave the demand column empty. And since it's has 0 demand, we can decrease the minimum pressure requirement to 3 meters. For the next node, let's give it a demand of 4 liters per second. And let's say this is some drought prone area, so we might want to increase our minimum pressure requirement to 10 meters. Here we have some tools to look at the data better, especially if we have lot of nodes in our network. We can click on the column headers to sort the rows on that column. So we can sort it by node ID, for example, or node name, elevation, demand, anything. We can also search for nodes using the search bar. So let's say we search for 0 node. Now it displays only those rows that have 0 node. To clear the search, just press the cross at the right side. We can also delete nodes if we have added them by mistake. Let us first add a couple of dummy nodes. So again, you can see that it adds 4 and 6. Now to remove both of them, we just select them and press delete. Are you sure you want to delete? Yes. Next, we come to the pipe section. The functionality of this panel is very similar to the nodes panel. As before, we have a table with the pipe information, and we can do similar things like add, delete, search. Let us go over the columns for that pipe table. Pipe ID. Just like the node ID, this is the unique integer identifier for each pipe in the network. Start node. This is the node ID of the node at the start of the pipe. End node. Similarly, this is the node ID of the node at the end of the pipe. This is the length of the pipe in meters. This is the diameter in millimeters. Normally, diameter is calculated by the optimization, and this field is left empty. But if the pipe is using some existing diameter, then the value can be set here. Roughness. This is the Hazen-Williams roughness coefficient for the pipe. This needs to be provided if an existing diameter is being used. If left empty, it takes the default value provided in the general screen. And finally, parallel allow. If the pipe has an existing diameter, then this option can be enabled to allow a parallel pipe to be placed in case the primary pipe is not enough to serve the demand. As in the node screen, to add pipes, simply click on the Add New button. Let's quickly add 3 pipes and put in some sample values. So this is our first pipe which connects nodes 1 to 5. It has a length of 100 meters, 1000 meters, and let's leave diameter and roughness empty. The next pipe connects nodes 1 to 2 and it has a length of 100 meters. Again, let's leave everything empty. Finally, our last pipe connects nodes 2 to 3 with a length of 1300 meters. Next, we come to commercial pipes. Here, this is where we enter the data for commercially available pipe costs. Each row in the table is simply the diameter of the pipe, its head loss roughness coefficient, and the cost per meter of the pipe. We can leave the roughness value blank and it will take the default value of the roughness from the general screen. Let's add some sample values for the commercial pipes. Our smallest diameter of 63 millimeters has a cost of 116 rupees per meter of that pipe. Next, a pipe of 75 millimeters with a cost of 172. Similarly for 90 and 110. We have now entered all the relevant data for our network and can move on to optimization. If we want to clear all the data, we can click on the reset button. This will remove all the information that we have removed. So that is why it is prompting us to save before continuing. So let's just cancel. Now that we are done entering all the network information, let's move on to optimization. Click on the Optimize Network tab and simply click on Optimize. Since this was a very small network, we are very quickly done. For a sample network, we got a done message, so it means we were successful. We are then directly taken to the results screen where we can see the nodes, pipes, and the cost details in different tabs. In the nodes tab, we can see the head at each node, the pressure, resultant pressure, and as we can see, all of it exceeds the minimum pressure requirement at that particular node. In the pipes tab, we can see the diameter of the pipe that was chosen. So for example, for the first pipe, a diameter of 75 millimeters was chosen. For the next 2 pipes, a diameter of 110 meters was chosen. The head loss that was there in the pipes and the head loss per kilometer in the pipe. And also the cost of that pipe. In the cost tabs, we can see the summary of the cost diameter wise and the net total cost of our network. Sometimes if some information is missing in the input, then we will get an appropriate warning message. Let's try that by removing the source head from the general screen. So let's go to the general tab and remove the source head. Now let's say if we try to optimize, it will give us a warning message saying please enter the source head. So let us re-enter 100 and optimize again. Sometimes if the network is infeasible, we get a network cannot be solved message. In our sample project, let us look at the pipe diameters chosen. Here we see that for pipe ID 3, a diameter of 110 meters was chosen. In our original input, let us fix the diameter for this pipe to 63 millimeters. Now let's try optimizing this network. As somewhat expected, we get a network cannot be solved message. This means for this network input, no allocation of pipe diameters can satisfy all the demands of the network. Let's see if we can do something in such a scenario where a pipe has existing diameter that is too small. Let's go back to the pipe input panel. Here for pipe 3, we can tell the system to allow parallel pipes if required. Since we already know that a 63 millimeter pipe is not enough, the system will try and place a pipe in parallel to satisfy the network. Let's try optimizing again. This time we are successful. Let's go to the pipe results tab to see what happened. The system added a 75 millimeter pipe in parallel to the 63 millimeter pipe that was existing. And this was able to satisfy the network where a single pipe could not. Note that the original 63 millimeter pipe does not contribute to the cost since it is an existing pipe. Now that we have entered all these input details and got the result, we would want to save this information for future use. Click on the Load Save Files option. From here, click on the plus sign next to the Save Input file. We can save the input as an XML or Excel file. Let's choose the Excel option. This opens a standard Save dialog box from where we can select the location of our file and change the file name if desired. Let's just save it as it is. Let's quickly look at the Excel file that is generated. Here we see all the information that we had entered, the general information at the start, then the node information, the pipe information, and then finally the commercial pipe information. We can similarly save the output information as an Excel file. To load this file, let's go to a fresh session of JalTantra. Open the site in a new tab. To load the file, click on Load Save Files, expand Load File, and then choose the Load Excel File option. Let's select the input file that we have just now saved. All the information from the Excel file has been loaded into the different screens. We can click on the Optimize button again and check if we get the same results as before. One thing that we had skipped earlier was the Maps tab in Network Description. Entering all the node and pipe data can be very time consuming, especially if you have a large network. Also, data like node elevations and pipe lengths need to be found either via surveys or through some GIS tool. Rather than manually entering all this data, we can use the Map tool. The system uses Google Maps and allows to add nodes and pipes to the map and then export all the details to the node and pipe tables we saw earlier. We can search for a location by name or by latitude longitude. Pressing enter takes us to the node. Here we can add a node at the location. On adding the node, we can edit its details like name, node ID, and whether it is the source. Let's mark it as the source and click Save. At any point, to edit the details of the node, we can right-click it and press Edit Node. This brings up the same menu as before. We can also delete it if required. These options, as well as several others, can be brought up by simply right-clicking anywhere on the map. To add node, simply click the Add Node button and click on a location on the map. As before, we see the edit options for the node. Let's change name to Node 5 and ID to 5. We can also add a node by right-clicking a point on the map and choosing Add Node. Add node here. To add a pipe between two nodes, click the Add Pipe button and then click the Start node followed by the End node. So let's create a pipe from node 1 to node 5. The pipe that is added is automatically added along the road network. This also shows the elevation profile of the pipe. Hovering over the chart shows the distance from the start node and the elevation of the pipe. To close the chart, we can simply click the Close Chart Elevation button on the top. display the chart again, we can simply click on the pipe. In case you don't want to add a pipe along the road, but instead you want to add a direct pipe, you can also do that. Simply right click and choose the option to add direct path. Add a direct pipe, and then let's select node 5 to node 2. So here, instead of adding the pipe along the road, it has added a direct pipe. Here in the elevation profile for the pipe first, we see a point which is at a higher elevation. So we might want to add an intermediate point at this position. Simply right click the pipe at that position and choose split the pipe. This will add a dummy node in between the two nodes. Nodes can also be moved by left clicking and dragging them on the map. Let's choose node 3 and put it here. Once we are done, we can export all this data to the node and pipe tables by pressing the transfer data button. If the transfer data is confirmed, it will overwrite any previous data that has been entered. Once the data has been transferred, we can enter the additional details like node demand and any existing pipe diameters. For now, let's just click no and work with the previously entered data. In the end, we have the help option. Here we can see the units used for the various parameters. Elevation head and length use meter, demand uses liters per second, minimum pressure also uses meter, and diameter uses millimeter. We can also download some sample input and output files. For extra information on JalTantra, you can visit cac.itb.ac.in/jaltantra. For any queries, please contact me at huda.nikhil@gmail.com. Thank you for listening and hope you found this tutorial on JalTantra very useful.